Hi everyone, in this video I'm going to be proving two formulas. The first is the formula for the area of a parallelogram, and second is the formula for the area of a trapezium. So let's start off with the parallelogram. So when we have a parallelogram, and when we know these measurements, we know the base of it, and we also know the vertical height of it. What we can do is we can just split this parallelogram in half, just like that. And by splitting it in half, we have created two triangles. So we have one triangle which is over here and one triangle over here. So all we have to do is find the area of both triangles and add them up. So let's take a look at this triangle over here first. The base of that triangle is B, and the height of it is just h. We know the area of the triangle is just half of the base times height. Now, because this is a parallelogram that we're looking at, the top of this also has a length of b, and we can use the same formula to find the area of this triangle over here. So all we have to do is add the area of that triangle, and the area of that triangle is again just half of base times height. So when we have half base times height plus half base times height, you just get base times height. And this is the area of this parallelogram, just the base times the height. And remember that this height is the vertical height of the parallelogram. Now let's move on to the area of a trapezium. So let me sketch a trapezium over here. Now for this trapezium, we know a few measurements. We know the base, we know the top of it, and once again, we're given the vertical height. How do we find the area of this trapezium? Well, what we can do is we can slice this trapezium across just like that. By slicing it across just like that, again, we have created two triangles, similar to the parallelogram earlier. So we can start off by finding the area of this first triangle here, and then we'll find the area of the second triangle and add them up. So the area of this first triangle over here is again just half base times height. The base of this triangle is just b, and the height is just h. So for the first triangle, its area is just half of base times height. Now we have to find the area of the second triangle. Now you may not be so used to finding the area of triangles like this just because this angle here is obtuse. But no problem, we can use the same formula, half base times height. So in this case, here we just have the base of this triangle as a, and the height of it is just h. Now before we move on, I just want to stop for a moment and just show you and point out why this works, right? So let me just go ahead and draw a shape that looks a bit like this. So this big shape that I have just drawn in red, that is a parallelogram. And notice that the area of this triangle that we're looking for is exactly half of the parallelogram. So the parallelogram has an area of base times height. The base of the parallelogram is this a, and the height of the parallelogram is just h. So the area of that big red parallelogram over there is just ah. And since the triangle is half of it, the area must be half of ah. So just in case you weren't convinced, hopefully that convinces you that we can use the same formula. Now, notice that both of these have half in them, so we can factor out the half. So we get half bh plus ah. And since both of these terms here have an h, I can factor that out as well. So we get half of b plus a, and then multiplied by h. And that is the area of this trapezium. Now here's a bonus. So I'm going to be showing you one more proof for the area of a trapezium, and I think this proof is really nice. So again, let's just sketch a trapezium over here. And again, we know that the side length here is just a, whoops, no, let me call that b, and then a, and then our height. what I am going to do now is that I am going to multiply this area of the trapezium by 2. Hold up. Okay, so we want to find the area of the trapezium. I'll just call the area A. Right, so that's the area we're looking for. Let me multiply that area by 2 first by drawing another trapezium. I'm going to be rotating the second trapezium though. So it is the first trapezium, but just rotate it 180 degrees. It'll look something like this. Right, so this here is the same trapezium. It has the same lengths, A, B, and it has the same height. Now, notice that over here we have these two sides which are parallel, and they are also parallel to those. This and this are also parallel, and this are parallel. So now what I'm going to do is I am going to take this second trapezium, I'm going to highlight that, and I am going to stick it to the first trapezium, just like that. Alright. So now, over here, the area of the second trapezium must also be A since both trapeziums are the same. And the total area, so the total area that we have here is just 2A because we have A plus A for two trapeziums. So now that we have stuck them together, notice that this whole shape now, this whole big shape here, this whole shape is just one big parallelogram. And we know the area of the parallelogram. The area of the parallelogram is just base times height. What is the base? The base is just B times A. Whoops, sorry, not B times A, I mean B plus A. So the base of it is just B plus A. And the height of it, we got to take the whole thing and multiply that by our height h. But we're not done yet because we found the area of the big parallelogram, but our original trapezium was just half of that. So what we have to do now to get it is to divide both sides of this equation here by 2. So by dividing by 2, we cancel out the 2 over there, and we are left with the area of the trapezium, which is simply half of B plus A times h. So that's it for this video. Hopefully it was interesting, hopefully it taught you something, and thank you for watching. Have a great day. Bye bye.